And I would remind you to check out our bitshoot.com/smAshomash page as well. The official BitChute page of the Smash News Network, least busted name in news. There's exclusive content there, such as our video about hydroxychloroquine. And twitch.tv/smAshomash is a fantastic live streaming platform. It's why we use it on the regs. Thanks to our new subscribers over on YouTube. Don't forget to press like, subscribe, share, etc. Tell your friends, foes, science noobs, and science pros about the channel, if you would be so kind. And this is our Cosmology segment. So today's Cosmology segment should be interesting as always. And let's get to it. First in today's Cosmology segment is the NASA astronomy picture of the day, which is of the Ant Nebula. A nebula which looks a bit like the ant, like an ant. So, and this is believed to have a sun-like star at the middle. It may be a binary, but it's not fully understood how this nebula was created. So perhaps this gives some insight into the evolution of a star like the sun. And I would remind our viewers that all stars are variable stars. All stars appear to be able to create all sorts of heavy elements without becoming supernovae and exploding as they do it on their surface. It's something we observe. And the Ant Nebula has what is believed to be a planetary nebula surrounding it. So it's quite a busy area there. And you can read more about the Ant Nebula. It's quite a famous nebula. Does it give us insight into the, quote, death, end quote, of our sun? I don't think so, as I'm not necessarily convinced that stars are born or die, as it's something never observed. Let's pick a random object on the Neil Gorell Swift Bat X-ray Observatory. I've already done so in show prep today, and today's random object coincides with number 833 at the Neil Gorell Swift Bat X-ray Observatory, which is Scutus X-1. So here's an interesting paper about Scutus X-1, dating all the way back to December 1967. And this is an odd pulsar in that it is a Doppler shift-induced radiation pulsar, perhaps. And we're not exactly sure how it works, but this paper from 1967 was proposing some legitimate ideas about the production of all of the different spectra coming out of it. So it's obviously an X-ray emitter. It's also a radio emission source. So perhaps check out this paper entitled "The Doppler Effect as the Cause of the Splitting in Type II Radio Burst Spectra" from Scutus X-1. So here's Scutus X-1 in infrared. This is the 2 mass, and it's at a pretty busy part of space, folks, which is why you won't be able to see it in all sorts of different wavelengths. You can see how many objects are located in that part of the sky. It's quite close to the galactic plane, as you can see here. That's the Milky Way there, folks. And we'll zoom way in here. There again is Scutus X-1 in infrared light. Let's see if it shows up in any other wavelengths. Here it is on the Multi-Mirror project. That is X-rays from the XMM Newton. And let's see if it shows up in blue light. Nothing there in blue light. How about in UV? And it's not emitting in UV. Let's close out the views of Scutus X-1, the irregular and odd pulsar radio and X-ray emission source. Scutus X-1, today's random object. Let's talk about a new Octo Tiger astrophysics code model. It's just a model, folks, and it's a model designed to create a high-resolution animation, a model of 2 white dwarfs in close rotational proximity. Here's a little run of that for you. And I would note that the red arrows indicate stellar winds of over 1,000 kilometers per second. The blue arrows indicate slow stellar winds of 1 kilometer per second. It's the Octo Tiger simulation model. Is it good? Is it legit? I don't know. I have no idea. But it's an article here on SciTech Daily, The Breakthrough Astrophysics Code, Rapidly Modeling Stellar Collisions. And that's today's Cosmology segment. We'll have to say goodbye to Twitch. Bye, Twitch. But we'll bring you back for today's Meteorology segment, which should be interesting as always.